All right, guys. Thanks for joining. My name is Tyrone Visser. I'm the Business Development Manager for IoT and Linux for North America with WAGO. And today we're going to be talking about how to simplify IIoT remote monitoring. So I'm going to be talking about a case study that we did with a customer, and I'm going to show you a quick demo that I did just via video. Not enough time to do a live demo here, but if you guys do have questions, you can come to the booth and I can show you more on how I got it all set up. So if you're not familiar with WAGO, just as a global snapshot, we're about 8,600 employees worldwide. We manufacture products in multiple geographies across the world, but we're a German-based company based out of Minden, Germany. If you're not familiar with the history of WAGO, back in 1951, we initially started the company on the first patent of a spring cage connection technology. So as you'll see in a lot of electrical connections today, lots of connections use screws. But the spring cage connection technology was a really important change in the way that connection was done, especially for like mobile vehicles. The fact that it uses a spring cage eliminates the possibility of something like a screw loosening. So we've got a lot of experience in mobile applications, rail cars. Right now we do a lot of business with drilling rigs, any kind of heavy duty type of commercial environment, commercial industrial environment. That's kind of where we got our expertise. In 1977, we came out with the next generation of that, like the spring cage you would see today. And then in 1995, so I'm just checking my slide here. In 1995, we came out with, through the joint development of us and another German company here called Beckhoff, we came out with the first slice I/O system. So that's the first I/O system without a backplane, modular I/O system. And if you look at the I/O between us and Beckhoff, you'll see that the housings look very similar. So they are quite similar. The electronics are different, but you'll see that the housings are still the same. Just to go over some devices here, really everything that we offer here, and I'm the IoT guy, so I'll tell you about IoT stuff. Really everything that we offer here is a Linux computer. Even when you look at our PLC platform, it's just a Linux computer with a PLC runtime on it. And also I just realized that I'm supposed to stay in one spot. I'm a walkie-talker, so I'm going to try to stay in one spot with I/O points on it. So one of the benefits of running Linux on all of these devices is that, so for instance, these kind of the bottom tiers, these run an embedded Linux. It's not like a Debian Linux or an Ubuntu that you would see on a lot of general computers today. It's really a pared down Linux that doesn't have a package manager. There's no real way to install different types of software and applications on those devices until we started doing it with Docker. So Docker is basically like a virtualization platform, but instead of virtualizing a whole operating system, it just allows you to package and install applications to your device. And why that's important is because it allows us to install a variety of different third-party softwares onto our device. And it really enables us to do a lot with something that was traditionally PLC and only ran PLC applications, now can run a bunch of third-party software in conjunction with a PLC application or completely separate of a PLC application. In terms of the hardware that we have available, we have over 500 different I/O modules. We've got options for minus 40 to plus 70 degrees Celsius, so there's a ton of different options for I/O system. And what is our approach to IoT and automation? Well, we've always had this automation platform since the 90s. And recently, since we were able to run these Docker images onto these PLCs, we're not really a software company. We're more of a hardware company. So our goal and the way that we do business is we like to work with software companies. We like to integrate either their software onto the PLC or work with a company that has maybe a cloud offering that's similar to what we want and what our customers want, to provide a full solution to our customers. So we're going to be talking about that with the application today. I talked a little bit about Docker. One of the technologies that we're using for this application was Node-RED. That was something that we installed via Docker. Another important technology here is MQTT. If you're not familiar with MQTT, it's kind of the de facto cloud protocol. If you're sending data to a cloud, generally it's going to be in an MQTT format. It's also like the most common protocol used for IoT communications. It was built for the pipeline industry. I believe in the 90s, it really was built for low latency, low bandwidth connections. But it's been a really important protocol now because it's publish and subscribe messaging. So it's it's a very scalable application, scalable protocol for IoT applications. And of course, because a lot of IoT applications are remote, you can adjust quality of service levels to ensure that you're getting package transfer. So there's a lot of benefits to MQTT. One of the things we want to talk about is that we actually have enabled you to, you can download this software package, the MQTT K-Bus API is what we call it, and it allows you to interface with all the I/O points on board the I/O system via MQTT. So you can install what's called a MQTT broker right on the device, and you can interface with between a software and the physical I/O points on the device via MQTT. Why this is important is because it allows us to use a software like Node-RED. Node-RED is kind of what I'm showing here. This is the Node-RED environment. It's a flow-based programming environment. It's very visual. It's just drag and drop. It's based on JavaScript. So this is something that we would install via Docker, and then I can set up a remote communication to the device. I can actually program the inputs and outputs via MQTT, and I can repackage that information and send it to a cloud via MQTT. So we will show that in the demo. The IoT partner that we used for this application was a company called UbiDots. Not everybody is a cloud-based developer or programmer. Sending data to a cloud is quite simple, but actually doing something meaningful with the data is sometimes where it gets complex for a lot of people. I like UbiDots because they have these really beautiful drag and drop style dashboards. It's very quick and easy to get up and running with UbiDots, and the price is really nice for a scalable IoT application. If you need to scale something up quickly, it's not a ridiculous price point, so it's a good IoT partner for us. So looking at the application, what we're looking at here is a brownfield application, and by brownfield I mean this is where we were basically adding this infrastructure to an existing infrastructure at a manufacturing plant. So we had this manufacturing plant. The customer said, okay, well, we don't have any type of building management system there. We don't know if any of our machines are operating out of specification. Also importantly, we need to know if we're wasting energy, how much energy is consumed, can we reduce the energy that we're using for potential rebates. In terms of resolutions, basically what they want here is they want some remote data gathering panels that they could connect to wirelessly, aggregate this data from all these different positions on the plant floor, and then send it to a cloud, some type of cloud dashboard. So the dashboard was important, being able to visualize the data, but also being able to trigger alarms. So if a machine's operating out of specification, can I send a message to somebody so that they can do something with this information? And because they had over 800 locations across North America, it needs to be scalable. It needs to scale in the cloud because to operate it from a server from every different location just wouldn't make sense, and the cost would be too intensive. So it needs to be a cloud-based scalable application. In terms of software technology that we used, we're using that K-Bus, MQTT K-Bus API on board the controller to control the I/O via MQTT. We are aggregating all the data in Node-RED, and then we are sending it via Node-RED to the UbiDots cloud-based dashboard. In terms of hardware technology, we're using two different products here. It's for the remote data gathering panels, it's a PFC 100. So that's what that panel looks like. It's got a big Wi-Fi Bluetooth antenna on the top. So that's the PFC 200 that's collecting all the data points, and it's sending it wirelessly to this panel that's just got a screen inside of it. It's a screen with a basically Linux computer in it, aggregating the data via Node-RED, manipulating the data, and then sending it to the cloud. Also, there's some visualization that can be done at the operator level right on site. So if we were to look at the system architecture, for instance, facility 1, facility 2, up to facility 800, the architecture would be very similar. They have all these different remote panels and maybe some different types of wireless IoT sensors. They are aggregating this data, sending it wirelessly via MQTT to the edge controller panel, which then has a wired connection to the internet where we're sending this information via UbiDots. And the one thing that we'll also show you in the demo is, in terms of security, this is a TLS encrypted application. So it's using that standard TLS encryption. There's some security measures there so that the data is protected. Really, an application like this is just monitoring. There's no real control, but we could do control applications too. A lot of people are a little bit more leery about what you're controlling when it comes to connecting to the internet because, in the instance that you did get hacked, you could have some potential risks and side effects to that. But for a nice remote monitoring application, it makes sense. So the goal here was to find some energy savings. How do we save money on energy? We want to measure energy reduction strategies. It's just making sure that I'm on schedule here, which I'm doing pretty good. We want to figure out energy reduction strategies to reduce the financial impacts of the facility. We wanted to look at labor reduction, so if we only have to train people on 1 or 2 softwares as opposed to operating a SCADA system, operating this, operating that, putting all these different things together, how do we make this as simple as possible? And then equipment lifecycle, basically being able to send information to the operators to minimize the risk of downtime and reduce costs. So now I'm going to switch to my video. And this is going to be a blinding speed, so if you do have questions, I do have this demo set up downstairs, so I'm more than happy to talk about it. So first things first, I'm going to log into the controller. Every controller has its own web-based management, so I basically just have a static IP address set here. I've connected to the controller, and I'm just going through all the configuration steps to get it connected to the internet. So there's a couple things that I'm doing here to physically get that connection to the internet. Important part here is making sure that I have a time server set so that it syncs with the time on the internet and I can actually instantiate that connection. Then I am pulling up a terminal. I am connecting to the device remotely via a terminal here. And this GitHub page has a little configuration tool that we like to use. It's called the provisioning tool. So I'm just going to pause it here for a sec. So this WAGO provisioning tool is nice because it's a command line interface tool that you can just press 1, 2, 3, 4, and it will let you automatically install these softwares once you're connected to the internet. So, first things first, I want to install Docker so that I can start installing other applications on this controller. In this case, I wanted to install the MQTT bus daemon. I wanted to install Node-RED, so I kind of am just going through the steps here of installing a couple different softwares to get me up and going. So it's a little bit of specialized knowledge here, but not really too bad. So now once I get to the Node-RED programming environment here, the first thing I'm going to do is I'm going to download this, what's called a palette. They have all these different palettes on the left-hand side. These contain the nodes, and the nodes are what we drag in and we use to program the device with. So Node-RED lives and runs on the PLC, but we're just connecting to the interface that we use to program with is just a web browser. So I'm just connecting to this device via web browser on my computer, and I don't have to have any type of software or anything on my computer. I can just connect to the device, and I can start programming from this interface right on the device. So I've got this thing connected. I'm downloading the WAGO PFC palette. As I scroll down on the left here, you can see these WAGO PFC nodes. The first node that I have here is the WAGO KBus in node. And what that's doing is this is taking in information from the I/O bus so that we can do something with it. And it's via an MQTT connection on an MQTT broker that's sitting on the device. So the first thing I'm going to do is I'm going to go into my settings here, and I'm going to set the local MQTT broker. The server is actually sitting on board the device itself, so the IP address is just the IP address of the device itself. And then the cool thing about these modules, you can see here, the cool thing about these I/O points, so I'm just dragging in some digital input nodes into the flow, and then all I do to actually connect to them is just set the module number. So if I have a physical I/O rack, if it's the first module in the rack, it's module 1, and then I just look at what channel it is, channel 1, boom, I'm done. So I just set that addressing, and it will know which one is which. So I've set module 1, channel 1, module 1, channel 2, and what am I going to do next? So in this case, if you guys come down and see the demo, I'll show you how I have physically wired, but I basically have the inputs wired to the outputs. I needed some way to show you guys how I'm triggering the inputs, how the input is actually getting a message. So I physically have it wired, and I'm going to send this data. I'm going to send data to the output saying turn the output on, and that's going to show the input turn on. So it's just physically wired in the loop here. So these blue nodes that I just dragged in are called an inject node. It allows me to inject a value into this node. So I'm, again, setting up my digital output values. This is module 2, channel 1. Here I can inject any type of value I want. It can be a number, it can be a Boolean, it can be any type of value that I want. In this case, I'm going to set up 2 different values. I either want to inject a true or a false. And if I inject a true into digital output 1, it's going to turn it on. If I inject a false into digital output 1, it's going to turn it off. So that's simply what I'm setting up here. Okay, perfect. So I've got my digital output set, my digital inputs. I'm just testing here to show you. You can actually see the status turn true and false here as I inject those values. So we know that it is indeed working. The MQTT broker is indeed working. And then I'm connecting what's called a debug node. And the cool thing about the debug node is, you see I just plugged it in and turned it on. What that allows me to see is the value that's supposed to be coming out of the node. Because the information in node-RED runs from left to right, I'm basically just mapping and seeing the value that's popping out of this node. So on the right here, you can see it's coming out at a cyclical value because of the way that the K-bus container is running. But it's pulling this data out, and it's showing me, hey, I'm getting a false value when I submit false to it. Okay. Right. So now the one thing about the UbiDots dashboard is if I want to send it data, I can't just send it a true or false. I need to actually send it a number value. So if I want to represent a Boolean as a number, I can also use 1 or 0. So in this case, I'm basically setting up what's called a change node, and I'm saying search for a bool. If the bool is true, replace it with 1. So this is basically just an if statement, but it's an if statement in a node. So I don't have to physically write this thing out as an if statement if I'm not a programmer. I just know that, okay, if I want to change a value from this to that, I can use the change value. This is where it gets, I think the one part where it gets a little tricky. If I send number values to UbiDots, that's cool. It's getting a number value, but it doesn't know what's the variable. Like what is this information coming from? Which IO point is it coming from? I have no idea, right? So what I'm doing is I'm taking that number 1, and I'm going to set it into a structure, an object. So I'm going to create an object so that it knows where that number 1 is coming from. So when I do send it via MQTT to the cloud, it's going to know what that variable is called, and it's going to give it a name. So I just created a name for this one called digital input 1. The other one I created a name for it, just called it digital input 2. Cool. And then I'm attaching my debug just to show you what the output of that looks like. So we're going to run it again. I'm going to clear it, press true. Turn on the debug. Cool. Now we have a nested structure. We actually have an object called digital input 1 that's sending out a 1 value. Okay. Then I'm going to pull out a MQTT out node, and I'm going to set up this MQTT connection to the cloud. So I'm going to have to set up an MQTT broker. I'm going to have to connect it to the MQTT broker in the cloud for UbiDots. And UbiDots has a lot of information on how to connect it here. In this case, we're going to use TLS encryption, so it gives you a server that you need to connect it to and a port number that we're going to connect it via. I'm going to set use TLS encryption. It gives you some certs that you need to upload. So just showing you there what the upload process looks like to upload that TLS certificate. So I'm going to pop that in there. That's good. The next thing I need to do is for the TLS encryption, I need to give it a username. I will get a username as soon as I create a device in UbiDots. So I've gone to UbiDots now. I'm actually creating a new device inside of UbiDots. I'm going to call it Tyrone PFC. And PFC is what we call our controllers, programmable function controllers. So I'm just going to give this a generic name here. Uh-oh, we're going to time out. Yeah, it's the connection. That's okay. Hello? I will set up a personal hotspot to my phone. I thought I was going to be foolproof here with the video. Live demos, something can always go wrong. I thought a video, this is going to be perfect. There's no way anything can go wrong. I should have done a physical video right on the computer. Let's see here. Yeah, thanks. Oof. Let's see how it goes. Time are we at? 5:10. Okay, we're back in business. Okay, so now I'm creating that device in UbiDots. It's going to give me a tag. So I'm going to need some kind of tag to give it back to the, it doesn't like that time. I basically need some kind of tag to give it back to Node-RED. So that all of these steps actually just help you create that connection to the cloud, right? So I'm going to do this last step, tell it, hey, I want to send all this information to Tyrone-PFC at UbiDots. I'm going to set a quality of service level to 0. If you have any questions about quality of service, you can talk about it after. So I'm going to hit deploy. Cool. So it says at the bottom there, it's connected. So it should be connecting. Now I'm sending true and false, and ideally those true and falses should be sending all the way to the cloud. So let's see. Let's build a dashboard. So what we're going to do next is we're going to actually refresh this, and it should automatically show the variables that we've created. Perfect. Digital input 1 and digital input 2. Those both exist now and are live on the cloud. Okay, so we've got these two variables, and they're submitting values. We need to next go and create a dashboard. So we're going to go to data and dashboards. So we're going to create a new dashboard here. I'm just going to call it GTD dashboard. And hit submit. So now I'm going to add a new widget. And there's a ton of different widgets we can add here, but just for simplicity, I'm going to basically add an indicating light. So where's that indicating light coming from? Where's that information coming from? Well, it's coming from the device Tyrone PFC, digital input 1 and digital input 2 are the variables. So the cool thing about this dashboard is I could have hundreds of devices here, but all I'm doing is just going to those certain devices and pulling those variables. Here you can see that this is actually scalable, and it's nice because it's web-based. It does scale with size. So if you want to view this on your phone, it would scale nicely with the size of the interface of your phone too, so it's nice. So here I've got one indicating light for digital input 1 and one indicating light for digital input 2. You can see here that number 1 is currently set to on. I'm just going to drag these screens and rearrange them so you can see them. So here, as I toggle true and false here on digital input 1, you should see that changing. And there you go. So you could take analog values. We've got a 3-phase power measurement module you could add into there, and you could dashboard that or set condition-based monitoring in the cloud. So if your voltage spikes or your voltage is out of tolerance, you could set it to send an alarm to somebody. There's a lot of things you can do inside of UbiDots that we haven't really talked about. And some of the other modules I wanted to show you is, for instance, the analog modules. So these analog modules, depending on the sensor type, you can set that in the resolution. But the cool thing about this is you can actually scale the value. So if I wanted to scale the 4 to 20 milliamp value to like 0 to 100 PSA or something, PSI or something, right? I can actually set the scaling right in there without having to have another node. So just a nice way you can scale that data before you send it to the cloud, so you don't send it to the cloud as just some kind of a raw number. And yeah, that was what I had for you. If you guys have more questions, please feel free to come see me at the booth. I'll be downstairs. Thank you.